Welcome everyone. Today's lesson is on prisms and cylinders. We're going to first cover surface area, which in your Pearson Texas Geometry textbook is topic 14 section 2. And then we're also going to go into volume while we're here talking about prisms and cylinders, and that's topic 14 section 4. Don't worry about section 3. We're going to cover that with section 5 when we go over pyramids and cones. So first, I want to talk about what a prism is. A prism is a polyhedron, so that's a three-dimensional figure that has flat sides, with two congruent parallel faces that are called the bases. The other faces are called lateral faces. So what you see now highlighted in blue, those are our bases. Notice that they are congruent and parallel. And our lateral faces, well, they would be all the faces that aren't shaded in right now. And just to kind of keep in mind, we've talked about what that word lateral means. So lateral means sides, like your lateral muscles. So these are the faces that are on the sides. Now, I do want you to be careful with that because, of course, the figure could always be turned around so that the bases are left and right and the lateral faces are maybe at the top and bottom, but nonetheless, as long as you remember the lateral faces that are not the bases, then you're good. Next, I want to talk about what a cylinder is. A cylinder is a solid, which is another name that we use for three-dimensional figures. A solid with two congruent parallel bases. Sounds very similar to a prism, but the difference is that those bases are circles. So if you notice, we do have bases here as well, but they are circles instead. That's how we know it's a cylinder. So you can have a right cylinder, so that's when it looks like it's standing upright. Or it could be an oblique cylinder, and that's one I could give the formal definition, but pretty much it's slanted. The bases, or the line that connects the two bases, is not perpendicular to that base. Versus in a right cylinder, it would be perpendicular. So with prisms and cylinders, we're going to have to know these two extra words, which are altitude and height. So altitude is a perpendicular segment that joins the planes of the bases. So let's read into what that actually means. So it's a segment that joins the planes, joins the two sections that we have here, but it is specifically perpendicular. So that means it's going to form a right angle with I guess you could say the floor or the flat bottom. So similarly, a cylinder also has an altitude and it has to be perpendicular. So those lines that you see right here and here, those are our altitudes. Now another word that we have is height. Height is almost the same thing as altitude, but altitude is the line itself. It's referring to the segment. Versus the height, that's a numerical value, which is the length of that altitude. So while they are referring to the same line, one's referring to the line itself, the other one is referring to the length of that line. Now that we've covered what prisms and cylinders are, the actual point of this lesson was first to discuss surface area. So there are two types of surface area, as you can see here. The first one is called lateral area. The second is called total surface area. So here comes that word lateral again. And if you remember, that means it's sides. So the lateral area is the sum of the lateral faces. It's pretty much just adding up the area of all the sides, but not the bases. When would we ever have to talk about lateral area? Well, think about maybe if you're painting your bedroom. You're not going to paint the ceiling or the floor. You're only going to paint the walls. So you would have to know the lateral area of your room to determine how much paint to get. So we do have a formula for figuring out lateral area for both prisms and cylinders. It's actually the same formula. It's P times H, where P stands for perimeter of the base, and H stands for height. Remember, height is going to be the length of the altitude. Going back to perimeter of the base, that even though it's the same letter P, it might be calculated in different ways. For a triangle, you'd have to know the three sides of a triangle. For a rectangle, you'd have to know the length and width. For a circle, you'd have to know the radius to determine the circumference, because that's going to be the same thing as perimeter. So even though the perimeter might be calculated in different ways for different shapes, either way, as long as you find the perimeter and multiply it by the height, you'll have the lateral area. The next one is total surface area. So this is simply the sum of all the faces, including the bases. So going back to the bedroom example, it would be including the area of your ceiling and floor. So to find total surface area, normally abbreviated SA, we have to take our lateral area, which would be the sum of all the sides, but then add 2 bases. And now that you see a capital B, note that capital B is the area of the base. It's not referring to one single dimension or one side of the base. So if I were referring to one side, we would use a lowercase b. But since I'm using an uppercase B, that means the area of the base. So now seems like a good time to do a practice problem. Find the lateral and total surface area of the prism. So notice that this is actually 2 questions in one, because we have to find the lateral area and then the total surface area. And we have a rectangular prism shown here with these dimensions of 10, 5, and 4. So first, I want to find the lateral area, which I know is P times H, or perimeter times height. Here's my base with its side lengths of 10, 10, 5, and 5. To find the perimeter of this, I have to add them all up, so that would be 30 feet, and my height is 4 feet. So far, I've been able to find the perimeter and find the height. Now it's just a matter of multiplying them. So again, my lateral area would be those 30 feet of my perimeter, and my 4 feet of height. So when I multiply those together, I get 120 feet squared. Notice that because we're still talking about area, even though it's a 3-dimensional shape, units are still squared because we're referring to area. I'm not talking about the space that's inside the shape, but only the area. Think of if you're wrapping a Christmas present, you're using flat wrapping paper, so it's area, but you're using it to cover a 3-dimensional object. Alright, so now the next part of the question, finding surface area. So my total surface area would be my lateral area plus the area of 2 bases. So here again is my base. And if I want to find the area of the base, what's a rectangle? So that's length times width, which would be 10 times 5. So my area of the base is 50 feet squared. I have to add that on to the 120 feet I already found from my lateral area. So total, I have a total surface area of 220 feet squared. And that would be the end of that problem. So now here's another example problem, this time using a cylinder. Same prompt, find the lateral and total surface area, but this time just of the cylinder. Now I know a cylinder technically doesn't have faces because it's not a flat surface along the sides at least, but you can still find the area or the amount of wrapping paper again to cover around the sides even if it's a round shape. So my lateral area is going to be perimeter times height as usual, but since we're dealing with a circle, perimeter in this case is actually the same thing as circumference. And how do we find circumference? We have a formula for that. That's 2 pi r, which is radius, same thing as pi diameter. So really, we're doing 2 pi r, our radius of 2, times 8, our height, which comes out to a total of 32 pi feet squared. I could have, if I wanted to, multiplied the 32 and pi together, but I just wanted, for simplicity's sake, didn't want to have to use a calculator, left it in terms of pi, and it looks like a much neater answer. So now to find surface area. Surface area is, as usual, our lateral area plus the area of two bases, but this time, since our base is a circle, in order to find the area of a circle, we need to use pi r squared. So here is what one of my bases looks like. R is 2, so pi times 2 squared is 4 pi. So adding that 4 pi onto 32 pi, which was my surface area, I actually have to add 2 of those, I get a total of 40 pi feet squared. Let me go back there for a second in case you missed it. This is the entire problem. Please make sure that you write this down. Now, moving on to the next lesson, which is 14-4 about volume. Volume is the measure of the space a three-dimensional figure occupies. So we're actually talking about space now. So for prisms and cylinders, the formula is the same, which, as you can imagine, is why we group these two solids together. Volume is capital B times H. H still stands for height, and capital B still stands for area of the base. One thing I want you to note is that units will now be cubed. For example, centimeters cubed or cubic yards. And that's because now we're using up 3 dimensions instead of 2. So here's our third example problem, this time for volume. Determine the volume of the prism. So we have our formula, volume is equal to area of the base times height. Our base is a rectangle with units of 10 meters and 3 meters. To find the area of that base, it's length times width, or 10 times 30, which is 30 meters squared. So now I have to take that area of my base of 30 meters squared and multiply it times the height of 6 meters, which gives me a total answer of 180 meters cubed. Notice that here we do have meters squared times meters, which is how we get meters cubed. So that's just further proof that volume has units that are cubed. Here is a fourth example. So here's a fourth example of this time using a cylinder. This one's a little bit different because they're not asking us to find the volume. They're actually saying, given the information shown, what's the height of the cylinder. But since they give us information about what the volume was, I'm still going to use the same formula. So since volume is area of the base times height, I don't know what the full area of the base is yet, but I do know that my volume is 3,240, and that should say pi. I do fix that in just a second as we continue with the video. Centimeters squared. And my area of the base, since it's a circle, is pi r squared. Alright, so notice that now I have fixed it to where I've put that pi. You don't want to make little mistakes like that. And I know that my radius was 9 centimeters. So in my formula for area of a circle, I've put in 9 centimeters for my radius. And since I don't know what h is yet, I'm just going to leave it as h. When I actually square 9 centimeters, I end up with 81 times that pi that was in front, centimeters squared. And since I want to get height alone, I have to divide by that 81 pi centimeters squared. Doing so on both sides, we actually see here that the centimeters squared will cancel, the pi will cancel, and the 81 will cancel. So we're left only with height on the right side. And on the left side, the pi's will cancel here as well. Centimeters squared on the bottom, we have to get rid of 2 of the centimeters on top. So I'm just left with a single unit of centimeters. And 3,240 divided by 81 is just 40. So we've determined that the height is 40 centimeters. I could have given you another problem just involving finding the volume, but I figured I wanted to show you other ways that problems might be shown to you. The very last problem for today, a little bit of a challenge. Find the volume of a composite figure. Remember that composite means that they're putting two separate figures together. So what's the approximate volume of this aquarium to the nearest cubic inch? Well, this aquarium, it's partially a rectangular prism, but then the very end of it is circular. It looks like a cylinder, but it's not quite, because it's actually only half of a cylinder. So we'd still have to use the formula for a cylinder, but we'd have to cut it in half so that we're only left with the part that we want to add together. I do know for sure that my rectangular prism has, I guess you could say, a width or depth of 24 inches. And it has a height of 24 inches as well, but I don't really know what the length is at the bottom. I can't say it's 48 because that 48 goes all the way across, including the radius of the cylinder. So I don't know what portion of that 48 goes to the length and the radius, but I can find out. So here's how I can find out the dimensions that I need. Well, notice that the same 24 inches of depth or width are the same 24 inches that create my diameter of the cylinder. So radius must be half of that diameter, or 12 inches, meaning that the length must be 36 inches, because that's 48 minus 12. So first I want to find the volume of that rectangular prism, and the work is shown here. We need the area of the base times height. Since it's a rectangular prism, the base is a rectangle. And I know I need to do length times width times that height. My length is 36. My width is 24. Even though I have them a little backwards, it'll multiply to be the same thing. And my height is 24. So in total, the volume is 20,736 cubic inches. Now, I want to find the volume for the half cylinder. I did put the 1/2 in front of the volume to indicate that I only need half of the volume. So I also went ahead and put in that 1/2 on the other side, just to remind myself I need to cut my answer in half. So since the area of the base is a circle, it would be pi r squared times height, where I know that my radius is 12 inches. So I put in that 12. And my height is 24, since it must be the same height as the rest of the aquarium, giving me a total of 1,728 pi inches cubed. Since the problem specified round to the or approximate in cubic inches, I did go ahead and multiply 1728 times pi, which gives a total of 5,429 inches cubed. So what do I have to do with these two different volumes? Well, I need to add them together to get my final answer. So when I do so, I take that 20,736 cubic inches, add it to the half cylinder. So I really don't need this part over here. Of 5,429, and I get a total volume of approximately 26,165 inches cubed. And at that point, that's pretty much everything you need to know for this lesson for surface area, including both lateral and total, and volume for prisms and cylinders. Make sure you have your notes ready for your next class, and we're going to be doing more practice problems. One last note, if you maybe didn't understand one part of the video, feel free to go back and watch it again, or at least rewatch the one part that you needed help with, because you are expected to know this information once you get into class. Alrighty, see you then.